Hello and welcome. In this video, I'm going to take you through the process to calculate the percent ionization of a weak base. Now, remember that for a weak base, we often abbreviate that A-. It's a proton acceptor. So A- will accept a proton from neutral water to give you the conjugate acid HA and hydroxide ion. And so this is called a hydrolysis reaction because it basically splits water or reacts with water as this is happening, and it produces hydroxide. So it kind of makes sense that it's a base because it's forming hydroxide. Okay. Now the Kb, remember, is the base equilibrium constant, so it's products over reactants. Neutral water does not enter into this equilibrium because it's a liquid. Now, what we want to do here is show the equilibrium for sodium hypochlorite in water. So sodium hypochlorite is in equilibrium with hypochlorous acid and hydroxide ion. And the Kb for this is products over reactants, okay? And we know that the Kb is 3.6 times 10 to the minus 7 by referring to our handy acid-base table. Now remember that if Kb is much less than 1, it means that reactants are strongly favored and products are disfavored, okay? So our question here is, what is the percent ionization of 0.20 molar sodium hypochlorite? So of course we leave off the sodium because it's a spectator ion, and hypochlorite is OCl-. Okay, so the first step is to write out the hydrolysis reaction or the equilibrium there that's described, and refer to your table of weak bases and get the Kb value for that. Okay, and what you want to do is set up an ice table with the initial unchange in equilibrium there in the column, and then our ions of interest there written out. Water is a liquid, and I just put it here for sake of completeness. Okay. So we're starting off with 0.20 molar of the hypochlorite. Okay, we don't worry about water because it's a liquid, and we're assuming we have 0 of the products. Okay, now it's true in pure water you have very small amounts of hydroxide, but it's too small relative to the amount of hydroxide that's going to be formed by this chemical reaction. Okay, so just put 0 to make this table simple. Now remember where you put the plus x's and where you put the minus x's, okay? In this chemical reaction, we're going to have to react from left to right in order for there to be production of the products. And so minus x on the left side and plus x on the right side. As usual, you add your columns to get the equilibrium values or equilibrium concentrations, okay, for each of the substances, okay? Now that we have our concentrations, we need to focus on the equilibrium expression. So the equilibrium expression, as I showed you before, is going to be products over reactants. And then we plug in those values we've calculated from the ice table. The concentrations of the two products are both x, and the concentration of the starting material is 0.20 minus x. Okay? And this is where we make the assumption that the amount of x is extremely small in comparison to the molarity of our starting weak base. So we assume that 0.20 minus x is approximately equal to 0.20. Okay? And that's a very important simplification that we can make that allows us to skip over the quadratic formula completely. Okay? And so combine the terms there. X times x is x squared, and multiply, sorry, I'm maybe jumping too fast, but multiply each side by 0.2, and then take a square root on your calculator. So you would enter 3.6 times 10 to the minus 7, multiply by 0.2, and then you would hit the square root button on your calculator to get the final answer here. And I get x is 2.7 times 10 to the minus 4 when I round that off. Okay? Now the percent ionization formula is equal to the hydroxide ion concentration divided by the starting concentration of your weak base times 100%. And so this is from the formula from the OpenStax chemistry textbook. So the percent ionization is going to be 2.7 times 10 to the minus 4th divided by that original formula 0.2, and then you multiply it by 100 just to move the decimal place over 2 places, and the units basically are percent. So it's 0.14% ionization, okay? All right, so that classifies this substance as a very weak base and also a weak electrolyte, okay? So here's a problem for you to try. Follow the same procedure. What is the percent ionization of 0.20 molar sodium carbonate? So you're going to have to do 4 steps to do this problem. You're going to need to write the equilibrium reaction of carbonate reacting with water to form the 2 different things it forms. You're going to need to write out the equilibrium expression from your balanced chemical equation. Okay, remember it's products over reactants. Step 3 is to set up an ice table and calculate the percent ionization. And step 4 here is just to answer or ask the question, is carbonate a stronger or weaker base than hypochlorite? Okay. If something has a greater percent ionization, then it's going to be a stronger base. Okay. So thanks for watching. Please like, please subscribe. Have a great day.